All right, for this video we're doing Learning Target 6 Part 2, which is graphing an absolute value inequality, but we're starting by looking at our graphing an absolute value equality Part 1, Example 1. In Example 1, we graphed y equals the absolute value of x plus 2 plus 1 by using this table. So if you need to see that again, go back to the first video for Learning Target 6. But we came up with these points and this shape. So now I'm going to take a look at graphing the same problem, but changing the equal to a greater than. So we're graphing y is greater than the absolute value of x plus 2 plus 1. So step 1, we're going to graph the boundary line, and I use quotes around line because when you're graphing this absolute value, like we did in that example 1, it becomes a v. Now if we graph a greater than, that means the points on the v, the points on the boundary line aren't included, so we have to use a dotted v. So you'll see if we look up here, I've graphed the ordered pairs from example 1, graphed a dotted v, which is telling the reader any point on the v or on this dotted line, they don't work. And then there's shading here because we've already finished the problem, but that shading Sorry about that. The announcements had to stop the video for a second. But the shading came from step 2, testing a point that's not on the boundary line. And again, I'm using the word line in quotes because it's a absolute value v. So what we did was we took the point 0, 0, not on the v, and tested it. We plugged 0 in for y, plugged 0 in for x. So we got 0 is greater than absolute value of 0 plus 2, so 2. Absolute value of 2 is 2 plus 1 is 3. Is 0 greater than 3? False, which means no point on this side of the boundary, on the 0, 0 side of the boundary, will work, which means all the points up here must work. So let's just test one real quick. 0, 6. 0, 6 is right here. It should work. Let's see. If you put a 0 for x, you get 2 plus 1. You get 3. And for the y, you get 6. 0, 6. So 6 is greater than 0 plus, 0 is greater than 3. I'm trying to do too much in my head here. 6 is greater than 0 plus 2. So absolute value of 2 is 2 plus 1. So 6 is greater than 3. I'll get this right eventually. And that's true, which means 6 is greater than 3. That means we shade to include the point 0, 6. So it's a lot like graphing a linear inequality where we would graph the boundary and then shade one side or the other. It's just when you graph the boundary this time, you're graphing an absolute value boundary, which goes back to what we did in part 1 in the video part 1, graphing using those tables. Okay? Now the last one, which we already see the answer, the last one that we did in class was 3 absolute value of x plus y is less than or equal to 5. And I suggest that students get in the habit of getting y by itself for many reasons, but just for starters, because when we use the graphing calculator, y equals, to graph this in the calculator, we're going to need y by itself. So if absolute values weren't there, you would intuitively just subtract 3x. Well, same is true here. You subtract 3 absolute value of x. And when you do, you get this inequality, which means we need to graph the boundary line y equals negative 3 absolute value of x plus 5. So quick reminder, what's going to make that absolute value become 0? And that answer would be 0. So our table is centered at 0 with plugging in x values around 0. You can pause the video and check the work and confirm the ordered pairs. We also discussed in a previous problem that when you have a negative 3 in front of the absolute value like this, that it's going to make an upside down v. So now plot these points, and when we plot the points, we get this v that we have graphed here. Pause the video if you need to. And then we need to test a point that's not on the v. So I chose on the notes in the class to test 0, 0. Because it's just easy to plug in the numbers at 0, 0. And as long as the origin is not on your boundary line or boundary V, you can always use it. So I plugged in 0, 0, and I like to plug it into the original problem. So 3, absolute value of 0, plus 0 is less than or equal to 5. Less than or equal to 5. So we get 0 plus 0. We get 0 is less than or equal to 5. And that's true. 0 is smaller than 5, which means the point 0, 0 works in this inequality. So we take a look, 0, 0. If it works, then every point on this side of the boundary works. So we shade inside the V. And that's basically learning target 6 notes. Graphing inequalities that contain absolute values. You'll have a V, solid or dotted. Dotted if it doesn't have the equal to. Solid if it has the equal to. And then you'll shade up or down. Now let's try our little trick that we did on Learning Target 5 video. Our trick, if you will, would say if the y's are greater than the absolute value, well, y's get bigger as you go up. So if our trick's going to work, we should shade above the V. Y's are greater, so shade above. Let's see. We did shade above. And if it doesn't have the equal to, again, dotted. Okay. Now let's look at this last example, see if the trick works. We subtracted the 3 absolute value of x. So according to this, y is less than or equal to, solid line. Now where do y values get less than? Where do y values get smaller? They get smaller as you go down on the y-axis. So we drew our V, we did solid, and we shade below, shade down. Okay, so the trick's working. The trick's always going to work, but I want to make sure you understand why it works. So when we test points, we understand that we're shading this side because all those points work. So final questions. On this picture, does the point -1, 6 work? Yes, because it's shaded. Does the point -1, 2 work on this graph? Does the point -1, 2? And the answer is no, because it's on the line or on the V, but the V is dotted, which means points on the line don't work. Now for this graph, does the point 1, -4 work? Yes. How about the point 1, +2? Yes, it works because it's on the V or on the line, but the line is solid, which is telling the reader, telling us that those points work. If you plug in 1, 2 in this problem, you get 3 times 1, absolute value of 1, so 3, plus 2, you get 5. And 5 is less than or equal to 5. It gives you the 5. So the points on this V will always give you 5 on the left side, and because it has the equal to, it will always equal 5. So we shaded those. And that's the end of Learning Target 6.